Welcome back. It's our last segment of this lesson, and we are going to conclude by talking about two very important quantities. We call them instantaneous velocity and average velocity. But then before then, let's go back to what we had earlier on. You would see here that for velocity, you dividing change in position by change in time. Now, position, like I said to you, is measured in time, or change in position is measured in meters, it's measured in meters, and the time, we know the SI unit for it, it's seconds, S, okay? So that would mean if we have velocity as change in displacement, delta x up there, it means we're going to have meters up there, and we're going to have change divided by change in time, and we're going to have seconds down there. And what does that mean? That means that the unit of measurement for velocity is meters per second. But the same, obviously, it will be meters per second here for speed. Now, what is the difference? The difference is that this one is a vector quantity, so we have to show the direction. So because we're talking about Cartesian planes, we know that there is the minus axis and the positive axis. And what is also crucial about the motion we're talking about motion in one dimension. So motion in one dimension or along a straight line can only go forward or backwards. So we can say actually that the direction can either be positive or negative, or forward or backwards, or north or east, north or south. Let me just put south because that will be the direct opposite of that. West or east, okay? Things like that. So we are forced to show the direction when we're talking about velocity. And why? Because velocity is a vector quantity. Now let me just try and list this quickly. From the quantities that we have spoken about, the following quantities are scalar quantities. 1, distance. 2, time. 3, speed. All these are scalar quantities. We are only working on their magnitudes and no direction here. But then when we begin to talk about displacement, when we talk about velocity, these are vector quantities because they've got magnitude, they've got a size, how big they are, plus the direction in which the object is moving. So that becomes very important. You must understand that. Okay, now let's quickly go back to our initial drawing here, which has been a little bit messed up, but I think you can still see what we had when we started. We're talking about instantaneous and average velocity. So instantaneous, from the word instant. So we have instantaneous. So this is velocity at a point of the journey. So if we choose to know how fast was the object moving at point D, for example, at this point here, at point D, at that point, velocity at that point will be the instantaneous velocity of the object at that point. In other words, it is how it was and exactly what it was at that point. Okay? But then the question would be, what will be the average velocity? Average velocity is very easy to find. Why? Because you can just look at how far or how much change in position happened, which is your displacement here, and you divide by the time taken for the object to move or to change position from A to B. Okay? So that becomes average velocity. Okay? So your average velocity, for example, let me just do it this way. Say it took 5 seconds to change the object, for the object to change position from A to B. So it took 5 seconds. So delta T is 5 seconds. Okay, say it took that time for the whole journey. And when we measure the change in position, we find that that whole displacement is 10 meters. So your delta x is 10 meters. Okay? Your average velocity would be given by 10 meters. Remember, this is a displacement over time. So change in time, or the time is 5 seconds. And that gives you 2 meters per second. Now this is average, but it doesn't mean that this object has been moving at 2 meters per second throughout. Maybe at D it was at 5 meters per second, at C it was at 1 meters per second, but as a whole we find the average to be 2 meters per second. Thank you so much for watching. I hope you enjoyed the lesson. That brings us to the end of it. Watch again when we come back for the lessons in science. Thank you.